Welcome to Fun Facts Online. Today we're diving into a topic that sounds like science fiction, but is happening inside our heads right now. We're exploring the cognitive frontier, a new landscape where the lines between the real and the artificial are merging to create what philosophers call hyperreality. This isn't just about cool new gadgets. It's about how technologies like virtual and augmented reality are actively reshaping the very architecture of the human brain. We're embarking on a journey that has profound implications for how we perceive the world, what we remember, and even our fundamental sense of self. The term hyperreality was first introduced by French sociologist Jean Baudrillard back in 1981. He described it as a state where simulations of reality become more real than reality itself. In his view, our society has become so saturated with images and signs that they no longer just represent reality, they have become their own reality. Think about a meticulously crafted theme park, a perfectly curated social media feed, or a 24-hour news cycle. These are hyper-real environments that shape our perceptions and our desires. While Baudrillard was focused on media and consumerism, the arrival of advanced VR, AR, and artificial intelligence has made his ideas more relevant than ever. We're no longer just passive consumers of these simulations. We are active participants, and our brains are constantly adapting. Neuroscience gives us a powerful lens to see what's happening. The brain's incredible ability to change in response to experience, known as neuroplasticity, is the key mechanism at play. Immersive technologies aren't just entertainment. They create new sensory experiences that can forge new neural pathways and reconfigure old ones. This opens up amazing possibilities, from healing the brain to enhancing our skills. But it also raises critical questions. As we venture deeper into this cognitive frontier, we need to understand both the promise and the peril of this new relationship between our minds and our machines. The human brain isn't a static organ. It's a dynamic, ever-changing landscape of neural connections. This capacity for change, neuroplasticity, is exactly how hyperreality exerts its influence. Every time you put on a VR headset or interact with an AR overlay, you are actively engaging in neural remodeling. The principles are well established. For instance, London taxi drivers, who have to memorize the city's labyrinthine street layout, have been shown to have larger hippocampi, the brain region crucial for spatial memory. Similarly, musicians develop enhanced motor cortex representations of their hands after years of practice. The brain is a use-it-or-lose-it organ. What we practice and the environments we inhabit literally shape our minds. Hyper-realistic technologies are a powerful new toolkit for harnessing this potential. By creating immersive experiences, VR and AR can provide targeted stimulation to specific neural circuits, driving real changes in the brain. One of the most exciting applications is in neurorehabilitation. For individuals who have suffered a stroke or brain injury, VR and AR offer a unique chance to regain lost function. These technologies create safe, controlled environments where patients can practice motor tasks, like reaching for an object, without the risk of falling. A stroke patient with weakness on one side of their body might use a VR game that requires them to use their affected arm. The system gives real-time feedback and slowly increases the difficulty, promoting neuroplastic changes that lead to lasting improvement. AR is particularly useful because it integrates virtual elements into the real world. A patient can practice navigating their own home with the guidance of an AR overlay, which helps transfer skills from the virtual back to the physical world. Beyond the clinical, these technologies are also being explored to enhance cognitive abilities in healthy individuals. In education, AR can bring abstract concepts to life by overlaying 3D models on textbooks. Imagine studying biology by interacting with a floating, virtual cell. VR can create immersive simulations, allowing students to experience historical events, explore distant planets, or even dissect a virtual frog without harming a living creature. In professional training, VR is used to train surgeons, pilots, and other high-stakes professionals. Trainees can practice complex procedures in a safe setting where mistakes have no real-world consequences. This kind of experiential learning is highly effective. But there is a dark side to this digital neuroplasticity. The same mechanisms that allow us to learn also make us vulnerable to addiction and distraction. The constant stream of notifications, the endless scroll, and the allure of virtual worlds can lead to cognitive fatigue and reduced attention spans. Then there's the concept of digital amnesia. When we offload our memory onto our devices, relying on them for phone numbers, navigation, and appointments, we are outsourcing our cognitive functions. Over time, this could lead to a decline in our own memory abilities. Furthermore, if our brains become accustomed to the highly stimulating, often idealized worlds of VR and AR, will we find the real world dull by comparison? This could lead to a form of digital escapism, where people prefer virtual worlds to the challenges of real life. It's crucial that we use these technologies with a clear understanding of their impact. The self is not a static thing. It's a fluid construct shaped by our interactions with the world. In the age of hyperreality, this process of identity formation is becoming incredibly complex and fragmented. The curated personas we build on social media, the avatars we inhabit in virtual worlds, and the augmented selves we present through AR filters are all contributing to a new understanding of what it means to be a person. Baudrillard's concept of the simulacrum is key here. A simulacrum is a copy without an original. Our online profiles can become simulacra of ourselves, carefully crafted representations that might not resemble our offline lives. We post a highlight reel of our best moments, creating a virtual self that is an idealized version of who we are. This can cause cognitive dissonance, a disconnect between our online and offline selves. We might feel pressured to live up to our online persona, leading to anxiety and a diminished sense of self-worth. The constant comparison with the seemingly perfect lives of others also takes a toll on mental health. Hyperreality also has a contradictory effect on empathy. On one hand, VR has been called an empathy machine. By letting us step into someone else's shoes, VR can help us understand their experiences. A simulation of what it's like to be homeless can be a powerful catalyst for compassion. On the other hand, the nature of hyperreality can create detachment. When we interact through the mediated, often anonymous channels of the internet, it's easy to forget there's a real person on the other side of the screen. This can lead to a decline in civility and an increase in online harassment. Moreover, social media creates echo chambers and filter bubbles, where we only see opinions that confirm our own beliefs. This fosters an empathy for the like-minded, where we connect with our in-group but struggle to understand those who are different, which only deepens social and political polarization. As these technologies become more integrated into our lives, they will continue to reshape social interaction. The rise of the metaverse, a persistent interconnected network of virtual worlds, promises new opportunities for connection. In the metaverse, we will interact as embodied avatars, transcending physical distance. This could lead to new forms of community, but it also raises questions about presence, intimacy, and authenticity. When our interactions are mediated by technology, we must cultivate a sense of digital citizenship and develop new ethics for online interaction. Our perception of the world is not a direct recording of reality. It's an interpretation, a model our brain actively constructs from sensory information. In the age of hyperreality, this perceptual maze is becoming even more complex. Technologies like VR and AR are designed to hijack our perceptual systems, to trick our brains into accepting a simulated reality as real. VR does this by replacing our sensory input, creating a sense of immersion and presence, the feeling of actually being there. AR, meanwhile, overlays digital information onto our view of the real world. The brain is so adaptable that when we're in a VR environment, It works hard to integrate the sights and sounds with our body's movements. This process can be so convincing, but it can also lead to sensory confusion. For example, after a long time in VR, some people report a feeling of derealization, a sense that the real world is somehow less real. This is usually temporary, but it raises questions about the long-term psychological effects of sustained exposure. AR technologies change our perception in a more subtle way. By overlaying a constant stream of data, AR can be incredibly useful for navigation or accessing information. However, it can also lead to attentional tunneling, where we become so focused on the digital overlays that we fail to notice the real world around us. This has serious consequences in situations that require our full attention, like driving. Furthermore, the constant availability of information can lead to cognitive offloading. Instead of trying to remember something, we just look it up on our AR glasses. This could lead to a decline in our own cognitive abilities as we become more dependent on our digital assistants. The ability to manipulate our perception also raises a host of ethical concerns. What are the implications of using AR to create a perfect world, where unpleasant elements of reality are filtered out? This could lead to a sanitized reality, shielding us from harsh truths like poverty or environmental degradation. This could have a desensitizing effect, making us less likely to care about these issues. It could also create a society of perceptual haves and perceptual have-nots, where only those who can afford the latest tech live in a more beautiful world. We are at a pivotal moment in human history. The rise of hyperreality is a cognitive revolution. The human brain is adapting in ways we are only beginning to understand. The journey is fraught with both exhilarating possibilities and profound challenges. The potential benefits are immense. VR and AR are revolutionizing neurorehabilitation, creating more engaging educational experiences, and transforming professional training. However, the path is not without its perils. The same neuroplasticity that helps us can make us vulnerable to addiction and distraction. The curated perfection of social media can harm our mental health. The immersive allure of virtual worlds can lead to detachment. As we stand on the cusp of this new era, we face a choice. We can be passive consumers, allowing hyperreality to shape us in ways beyond our control, or we can take an active role in shaping its future, harnessing its power for good while mitigating its potential for harm. This requires a multi-pronged approach. We need more research into the long-term effects on the brain. We need to develop educational programs that teach digital literacy and critical thinking. We need to foster a public dialogue about the ethics of these technologies, creating a framework for responsible innovation that prioritizes human well-being. The future of the cognitive frontier is not a foregone conclusion. It's a story that is still being written, and we are all co-authors. By approaching this new reality with curiosity, healthy skepticism, and a deep commitment to our shared human values, we can ensure the next chapter of human evolution is one of growth, connection, and empowerment. The cognitive frontier isn't just a place we are going, it is a place we are creating, one neural connection at a time. Thanks for listening to Fun Facts Online.